Here's a quick video on an overview of the Nyquist-Shannon sampling theorem. It basically just says in order to reconstruct a perfect signal using only discrete points, you have to get points of at least twice the highest frequency in the original signal. And this is just a Wikipedia article. It goes through the whole thing, but I thought this animation was really cool. We can see that the angular frequency, once you do the Fourier transform, you'll get, it'll be perfectly symmetrical, right? And that's because any sort of sine frequency would have a perfectly symmetrical angular frequency, right? However much it goes up, it's going to go down, right? And that would be true of any even complex sinusoidal signals would have that exact same property. And this animation kind of gives you like an intuition of why you need to have at least double the frequency in order to encapsulate, right? In order to make perfectly recreate a signal. That's because you have to, you have to capture the whole range between the negative angular frequency and the positive angular frequency, right? So in this case, it looks like the highest frequency is about -10 and +10 omega, which would mean, of course, then you'll need a frequency. You'll need a sampling frequency of at least 20, right? Whatever units omega is in. And to kind of show you like an even more simpler like diagram. We have a really basic sine wave here, and basically what that animation, right, the Wikipedia article is showing was basically we need to sample the highest point, right? So the highest point of the sine wave along with the lowest point, right, in order to capture the whole data, right? Otherwise, if we don't sample enough points, we're not able to capture the full detail of the signal, right? And it has to be the highest frequency, right? Because that's the frequency with the most amount of detail. So in that sense, it makes sense. Since the sine wave's perfectly symmetrical, we just need to capture the highest point and the lowest point. And that requires 2 points, right, for every frequency, right, for every cycle. So that's kind of like the intuitive idea of why the Nyquist-Shannon sampling theorem. That's like the basic intuitive idea of why you have to sample at least twice the frequency of the original. There's a more formal proof that I'm not I don't know enough of to like explain well, but that's like the intuitive explanation behind it. And just for fun, I'm also going to attach this code as well. It's just code to basically deconstruct any sort of like sine wave, any sort of complex sine wave, and reconstruct it using the Whittaker, I think it's called, whittaker-shannon interpolation formula. So this is the interpolation formula. Those are the points, interpolation points. And yeah, you can kind of play around with this as well to see how the interpolation function actually works. But yeah, it's the Fourier transform is really quite neat.